All right, so what you see on the board is the same as this handout that you have with your notes on it, but we're just going to go through and highlight some things and know that some things kind of reiterate some things that are written here. So this is our statistics unit. Now, statistics to me is very similar to science fair projects that you did. So if you notice, there is a 4-step process when you do statistics, similar to science fair. So the first thing that you do is you need to formulate a question. That's your first task. Think about something that you want to know more about and you want to see what people think about that question. So, for example, one thing that you could ask somebody is their favorite sport: football, basketball, baseball, whatever. The second thing that you do is design and use a plan to collect data. So if we're asking you what's your favorite sport, what you need to do is go around and ask people, right? You need to figure out what people's favorite sport is. The next thing that you do is analyze the data. So the data that you get, especially if you're asking somebody your favorite sport, you're probably looking at what was the most occurring answer or what was the least occurring answer. And then the next thing that you do is you interpret your results and you draw some conclusions. So those are your 4 main steps. And if you think about way back in the day, did y'all do science fair projects in elementary school? I know some did. My daughter has not done a science fair project. She's done a couple of math fair projects, but kind of the same way. So you figure out what question you want to answer, you collect your data, you analyze the data, and then you make results to that. Okay? Now, data collection can be done in several different ways. So here's 3 types of ways that you can collect data. The first one is a census. A census is using all subjects, everybody that you have. So, for example, the U.S. does a census every 10 years from everybody in the United States. So you can ask your parents. For a while, they got one in the mail. I know for my first year that I got to do it, I got married in 2007. So 2010, in the mail came this like big packet, and we had to bubble things in and fill things in and send it back. And if you didn't send it back, they had your address, and they would go to your door and be like, here's a paper copy, fill this out, we'll come back and collect it. So it's a big process of getting everybody to answer. The last year when I did it in 2020, it actually came out as something online that we could do, and there were less questions, which I liked a little bit better. So it would be every 10 years. So in 2030, the next one will come out in 2040 and whatever. And that's how they get their data to figure out, like a big thing back in the day for us old people was how many TVs do you have in your house, or do you have internet at your house? Because that was some big questions. Yeah, it's just asking personal questions about you and your house. How many people live in your house? How much money you make? TVs, internet, things like that. Now back to this. It's a hard way to do that, right? Imagine you wanted to get a census of every single student at this school. Would it take you a short amount of time to do that? Yeah? You could find all the seniors who only come here one period a day. You could go and track down people who are out sick or who don't always come to school. It might take you a while, though, right, to do that. And actually, it would take a long time for some of you. If you think about that petition that was going around at the beginning of the year, it took a long time to find everybody. You can ask Brady. How long did it take for him to find everybody to sign that petition for the media center person? So doing a census is usually there's not enough time or money to gather the data that way. So another way that people do it is a random sample. A simple random sample is the best way to do it. Now, often when you do a simple random sample, you give each person a number, and then you use a random process of something like drawing numbers to see who goes in that. A good example of that is similar to the drug testing that you do in school. So I know this works really well for bigger schools like South and West. So if you play a sport or you drive a car, you're automatically looped into that drug testing sample. And so what they do is they kind of mix up the names and then they pull one out, and that's the person who gets drug tested. Another way of doing this is, or the best way of doing this is making sure that everybody is in order before you give them a number. So we're going to do this together. I need everybody to stand up and make a line in the back of the room, alphabetical order by last name. Go meet your classmates. So line up in alphabetical order by last name. I guess we're going right to left. Let's see if they can do this correctly. Braden and Riley, y'all switch spots. And Braden switch with Haley. There we go. That's better. Okay, now that everybody is in alphabetical order by last name, we assign everybody a number. So in order to do that, we're just going to count off. Okay, then you use a random number generator. So in our case, I'm going to use a calculator. So the calculator will randomize your numbers for you. There's also random number generators that are used in statistics textbooks. If you actually look to the back of a statistics textbook, it has a random number table, and that's a lot of times what we would use when I used to teach statistics, or you could just use something that's online. So I'm going to split y'all into two groups. So the lower number is 1 to 12, and I'm going to put 6 of you in a group. Now, the bad thing with this is it might repeat a number. In this case, it doesn't. So if you're number 12, 11, 2, 7, 5, or 9, you go to this side. All right. So now we basically formed two groups, right? We have this group on the right and this group on the left. A lot of doctors will use this random process in order to make two groups. So tell me the 3 steps that we did to make these random groups. What did we do first? Lined everybody up in alphabetical order. Then everybody got a number. And then we used a random number generator to separate into two groups. So this is how we make a random sample. Now, I'm going to skip some things here, and I'm going to go down here real quick because I'm going to talk about an experiment real quick while y'all are already in groups, and then we'll come back and look at the other things. So let's say that I'm a doctor, and I was trying to figure out a new headache medicine to use to see the results of it. So what I would do is do a random sample of my participants. You were all my participants, okay? I ordered you in alphabetical order. I assigned all of you a number. I used a random number generator to make two groups, and they're two equal groups. So this group here, I'm going to give them the headache medicine that I've come up with, and so you all get a pill. You all get your headache medicine. This group over here is getting a placebo. A placebo is a fake drug, but I'm going to give each of you a pill as well. So everybody takes a pill, okay? And then I'm going to look at the results to see if that helps your headache or doesn't help your headache. Now, if you're doing this, it's called a double-blind study. If I do a double-blind study, the participants don't know, and the doctor doesn't know who received what pill. So most of the time when you do these studies in the medical field, participants don't know what pill that they get. Doctors sometimes know and sometimes don't know. If the doctors also don't know, it's called a double-blind test. And then you can compare the results and be like, hey, 5 people in this group, it relieved their headache, but in this group, only 1 person did. Now, if they're taking a placebo, maybe that placebo helped that one person because a lot of times it's a little sugar pill, and maybe they needed a little sugar pill to help them get over their headache. You know, sometimes how you feel bad and then you drink like a soda and you feel better, or you eat something and you feel better, you know, and it maybe your just blood sugar is a little low. All right, but that's how you do an experiment. All right, y'all go back to your seats. A simple random test or simple random sample is where we divide into groups like we just did, and then we can test just some people or everyone. Now, a survey is another way to get information, and that's by asking questions. Depending on who asked the question, depends on how biased the survey is. Like, for example, if I went up to Haley and said, Haley, what's your favorite color? Say black, say black, say black. You know, that's a different way of doing it. This example came from the statistics textbook that I used to teach out of, and it said, if a police officer came up to you and said, have you ever drank alcohol? You might have a different response than if a friend came up to you and said, have you ever drank alcohol? So it depends on who's asking the question, and depends on how the question is asked, depends on your survey and those results. So surveys can be very biased. So be careful when you see survey results online or on TikTok or whatever, because it could be, well, who did they ask? What type of question did they ask? Was it a true false? Was it optional? Because a lot of surveys, if they're optional, they're either going to give you a good review or a bad review. Let's think about that. The only time that I gave McDonald's a review was a bad one, and I feel bad. Maybe I should give them some better ones. But, you know, if you think about it, if you're passionate about something, you're going to give a review for it, and it could be good or bad. Now, inferential statistics. Inferential statistics is if we gather information from a sample and apply that to the whole population. So we draw results and we apply it to the whole population. So let's say that I asked you guys in this room what your favorite sport was, and the result we got out was basketball. Then I could say, well, since my class liked basketball the most, the whole school likes basketball the most. Is that true? No, but that's what a lot of people do when they do inferential statistics, is they take information from a little sample and they apply it to the world. But that's not always true, right? So you got to be careful. All right, let's talk about our two different types of studies that we have here. The first one we have is an observational study. That's if we just observe something that's happening. You can also do an observational study when you're going fishing. As long as you catch and release and you don't change anything in the environment, then that is an observational study. So observational study is no changes to the environment or anything that you're measuring. So again, if we are at a pond and we go fishing and we get a fish and we measure the length and we weigh it, but we put it back, did we change that fish? Did we change the pond? No. Okay? Now, an experiment is where you implement a change or a treatment. So let's say that we go to the same pond and we throw in a shark. Then we start measuring fish. Did we change the environment? Yes. So that is now an experiment. Okay? Also, we could talk about our group of people that we just did with the headache pills. We give some the regular pill and some the placebo, which is the fake drug. So you need to make sure that you know what a placebo is. And then we'll see which one helps or doesn't help. Okay? So anything that implements a change is an experiment. The last thing that we have is a simulation. A simulation often uses technology to get results. So the one that I like to talk about with this is those infomercials. You know, you've probably seen those. Like they have, the one that I loved the best was this glue. So they had a flag flying, and they cut the flag, and then they used a special kind of glue, and they glued the flag back together. Then they wanted to test this flag based on hurricane strength winds. Now, I don't know about you, but I'm not going to go find a hurricane and put a flag up and then sit there and watch it to see if it rips apart in hurricane force winds. That's not what they did either. They built this little room with a big old fan in it, and they had the fan blowing at 100 miles per hour to see if the flag ripped. That's a simulation. Way back when in the 80s, there was this movie. It was called Project X, not the new Project X. That's a different movie. There's the old movie called Project X, and they used chimpanzees to fly airplanes. And so they had a simulator, so the chimpanzee was flying the airplane in the simulator. Now, what also happened, what was bad in the movie, is they put like radiation in the room that the monkeys were driving the airplanes to see how it affected their bodies, to see if you could keep flying through a nuclear reaction. And so, but then the monkeys got set free, so it was good. It's not a good ending. But anyway, that's something that you would set up a simulation for, especially if you wanted to be a pilot. You're not going to put a 18-year-old in a $2 billion airplane and say, good luck, go fly that plane and let's see how it turns out, right? We're going to do a simulation with that. So everything on the front of this sheet is basically things that you need to know, but they're just more like definitions. On the back, we get into more of the math stuff, and it tells you how to collect data. But we're going to do that together. So let's collect some data and then see if we can find it to help us kind of do these problems that we have. And this is the stuff that we're going to be looking for. So let's do something easy like shoe size. Okay, so we go around the room and everybody tell me your shoe size, and we'll collect that data. Shoe size. 10.5. 9. 14. Levi. Okay. And here I am coming in at 6.5. All right. So these are shoe sizes from our class. So what we're going to do is we're going to take this information and we're going to put it in our calculator and generate all these different things that it talks about. So here's how you put the info in your calculator. Let's see. Hold on. Let's see if I can do this with holding down. Maybe I can pull up my calculator. It's not going to let me pull it up at the same time. But first thing that you do is you hit Stat and enter on Edit. Now, if you have things typed in your list, you go up to the top where L1 is highlighted and hit Clear and Enter. You always want to use Clear, never delete. So does everybody see L1? Okay. It's going to delete the list off. So here, I'll show it to you just so you know. If you go up here to the top and hit delete, it's not going to let me right now, then it takes the list away, and we don't want it to go away. So if you hit Stat 5 Enter, it will come back, though. So there's a way to get it back, and it says it there on your paper. But let's type in our shoe sizes. Everybody type those into your calculator. Type them in list 1. Hit Enter after each number. Yep. Hit Enter after each number. So Stat Edit, type them in, and hit Enter after each number. Stats right there. And Enter on Edit, and then type in all those numbers. And double check them, because if you type in one number wrong, it's going to get the whole problem wrong. Okay? So you need to make sure that you've typed in all of these numbers and typed them in correctly. Okay, I'm going to have to let me steal your calculator, and then I'll type them into the one on the board. Well, let's hope that you did. We're seeing in a minute. I missed one number, but that's okay. I'll just type it in with the other ones. And I think I missed a 7.5. 8. Yeah, there were 3 7.5s. Okay, I missed one, but it's okay. It's all in there. You should all have 13 numbers in there. So now once your numbers are in, now you're going to hit Stat, right arrow to Calc. Hey, guys, are y'all listening back there? Because I don't want to have to repeat myself 10 times while y'all are giggling. Y'all good? Is something wrong with the calculator? Okay. So now you hit Stat, right arrow to Calc, and you're going to choose option 1. This is called our one variable stats. Now, yours may not say any of this, and if it doesn't, just hit enter. If yours says this, just go down to calculate and hit enter. Now, on your paper, I haven't listed out what each number means, but I'm going to go through it with you just so that way you know. The first number here, the X with the line over it, is your mean. So it's our average. Our average shoe size is about 9. The EX, the E is actually a Greek letter that stands for sigma. So those of you who take, those of you who take Math 4, or if you're taking stats in college, then you'll hear about this a lot. It means that you add up all the X's that are there. So if we added up all of our shoe sizes, we'd get 119. The next one is if you add up all of our shoe sizes squared, which you will learn how to use those when you take stats later. Then you have this SX. S stands for standard deviation. Standard deviation is how spread out the data is from the average. So it's not too far spread from our average of 9. Most of the data is within 2 units of 9 is what that means. Yes, Grayson? We're round to 2 decimal places. Yeah. This one is actually a lowercase sigma, but it also means standard deviation, but it's standard deviation of the population, which is a little bit different. So the 2 that we mainly look at in this section is the first one, which is our mean, and then our standard deviation, which is the SX. Now, all the ones at the bottom are really important, so if you hit the down arrow, you can get the rest of those. N equals 13. N is your number of data samples that you have. We had 13 data samples. Then we have our minimum. Q1 is the median of the first half of the data. Then we have our median. Q3 is the median of the second half of the data. And then we have our max, which was 14. We're going to talk about that in a minute. Now, these 5 things right here are what you use to make a box and whisker plot. So if you ever made a box and whisker plot, maybe in elementary school or maybe Math 1, you have a box and then you have your 2 whiskers. So this is the min, this is your first quartile, the median, your third quartile, and your max. We don't have to make box and whisker plots anymore, but that's what they would look like and where the data would fall. Now, next thing on your paper, I gave an example for you on your paper, but then the bottom part here is the margin of error. Now, so far, they have given you this equation on the EOC, so I don't see reason why they would take it off. But this is how you find your margin of error. Your margin of error is about 2 times S over square root N. S is the standard deviation, and N is your sample size. So the margin of error for our data is 2 times 2.29 over the square root of 13. And you can type it in exactly like that into your calculator. So our margin of error is 2 times 2.29 divided by the square root of 13. So our margin of error is 1.27. Now, what margin of error is, it's the amount of error that we're off from the population. So our population would be students that are in your age. I guess you could throw my shoe size out. But students that are in your age typically have an average of about 9 with a margin of error of 1.29. And when you get more into statistics, it'll make a little bit more sense about how the margin of error works. Now, this last sentence on your paper is one of the most important sentences that you guys will have. So make sure that you highlight, star, underline, whatever you need to do. As the sample size increases, the margin of error decreases. So what that means is the more samples that we get, the less off we are, right? That would make sense based on our population. So we could say most students in Stokes County have an average shoe size of 9. Well, if we decided to not only sample this classroom, but our whole school, we would get a closer to the population average. If we decided to sample all the students at North, West, South, Early College, and Meadowbrook, we would have an even better idea of all the kids in Stokes County who have this shoe size. So the more we get, the less we're off. And that's what that last sentence means. All right, for homework, you have this packet. Some of the questions come straight from here. I am going to be reading through this. So if you only write down partial sentences or you only write down part of the stuff, you're not going to get full credit for the problem. I want full sentence explanations on these, okay? So like part 1 says, what are the 4 steps? You write down all those words, not just the words we highlighted. Write down all those words. When it says, describe a situation that can be modeled using a treatment and control group, you can describe the one that we did in class, but I want full sentences. Don't write headache pills. That tells me nothing. Describe a situation. Let's see. When you get back over into the second page, when it says the word explain, full sentences. That's on problem number 6. Number 7, describe a method. Provide enough details. That should be some full sentences in 7A. Now, 8 is just multiple choice, and it says that. But again, in 9, Part A says explain your reasoning. Part B, describe an appropriate method. So you need to make sure you describe, again, full sentences. Any questions about your homework? All right, you only got about 15 minutes now, but this is not due until Wednesday, so you can work on it tonight and tomorrow night, maybe a little bit in class tomorrow as well.